In this video, we will be discussing Chapter 1 of your textbook, The Importance of Management Information Systems, or MIS for short. But first, a quick note about lecture videos in this course. Even though I'll be covering most of the chapters in videos like this one, it's still important to do the readings, as content from the readings will come up on quizzes or the final exam. These videos are meant to be summaries of content you'll be finding in the text, where I cover the most important points and add additional and supplemental information to the readings. They'll not give a complete picture without first reading the assigned chapter, and when we get to quizzes or the final exam, you'll be at a significant disadvantage if you only watch the lectures. With that said, before watching this video, I highly recommend reading Chapter 1 and watching the previous Intro to Business video lecture. I also have some recommended MyLab homework listed that you should attempt after doing the readings. Recall that the MyLab homework is highly recommended, but ungraded, so optional. So let's jump right into Chapter 1 with the question, what is an information system? From our last lecture, we know that the textbook definition of information systems is a group of components that interact to produce information. We also talked about information systems existing long before computers in the form of paper, filing cabinets, card catalogs, ledger books, and most importantly, people following procedures to transform data into information. But when we were discussing information systems in this course, what we are referring to in particular are computer information systems. When data, computers, and people come together following predefined procedures to produce information, we have a computerized information system. Our text defines computer information systems in terms of a 5-component framework, splitting computers into hardware and software as shown in this diagram from your textbook. Hardware is essentially any part of your computer or tech infrastructure that you can physically touch. That is, any electronic components, gadgets, or devices that input, process, output, store, or communicate data according to the instructions and rules encoded in the computer or device's software. So this could be a wide range of things. It could be devices that you commonly use. For example, it could be like a phone, or it could be something like a tablet or a desktop computer. So a tablet, for instance. Probably pretty familiar with those general things. And it could also be like keyboards, mice, any sort of accessories that are physically used with your computer. But it also could be the components that are inside your computer. So for example, we could be talking about hard drives. That would be a disk-based hard drive for something like a desktop computer. Or it could be like a laptop hard drive, smaller, but same idea, still mechanical disks inside it. Or it could be a solid-state drive. These are the more modern hard drives that are just chips on a board. And these have some advantages. They tend to be faster because they don't have moving parts. So, for example, this solid-state drive would just be chips, whereas a hard drive with a disk would look something like this. This has the case off. So we have a big spinning glass disk in here, and a little arm that's moving constantly to go back and forth and read the data off the disk. It could also be components like the CPU. I have an older Pentium CPU here. Or the RAM in the computer. It could also be like the motherboard, cables, any part that you could physically touch. So this can also include other things that aren't necessarily right in front of you. So there's also many hardware components that are part of our computing infrastructure that we don't commonly see. This would be things like servers, networking hardware like routers, switches, gateways, and things like that. These would be things that would probably be handled by your ISP, or if you're at the university, probably by their Western Technology Services, and they'd be in like data centers and things like that, but are still critical for information systems because they're sort of connecting the computers and handling the things in the back end. So hardware is basically any physical thing that's part of your computing information system. And that could be things that are right in front of you, like your laptop, your desktop, but it could also be hardware that's in the data center, or even the physical cables running between your computer and the data center. So moving on to software. Software are the parts of the computer that you can't touch. Even if you were to open it up, and you're not concerned about any kind of risk to the computer or yourself with electric shock, you still wouldn't be able to see the software. So more specifically, software is instructions for the computer. These instructions are normally expressed as computer or machine code that can be interpreted by the computer hardware. These instructions are typically created by humans using a programming language that's understood by the computer. What is shown on the screen right now is an example of code written in the Python programming language. As users of computers, we typically don't encounter software in the raw code form, but rather as a package we purchase or find already installed on hardware. For example, things like Microsoft Word, Excel, Access, the diagram editor, and Notepad++ are all examples of software that we would purchase or download for free. But software can also include things like operating systems, such as Windows, macOS, or Linux for desktop and laptops, or iOS and Android for phones and tablets. It can also include more low-level software or instructions that comes built into your hardware, which you don't install, manage directly, or even think about much. For example, modern cars have computers in them that help tune the engine and monitor a number of sensors. And usually this isn't installed on an actual full-blown computer, but on things called microcontrollers, which are these little chips like this. This one might be a bit hard to see, but it is an 18 mega microcontroller, which is programmable, usually in C programming language or C++, and it's very popular with hobbyist developers because it's very easy to program and it can be used in things like robots, IoT devices, like turning a light switch on and off, and things like that. It's not going to be as full-blown as a computer in terms of what it can do, but it can handle simple tasks like turn on a light switch when I receive a certain signal, or make the robot drive forward when I receive a certain signal. So another example would be that there's software that runs on your television that changes the channels once you hit a button on a remote control. And there's even software in the microcontrollers on this remote control that tell it what kind of signal to send out when you hit each button. So even though we don't really interact with it directly, there are software on many things, including things as simple as your remote control, and they would not be installed on a full computer like you would put a disk into. Instead, it would become pre-installed by the manufacturer on things like microcontrollers that are going to be on the board inside of this remote. So moving on, we have data. As we discussed in the first lecture, data is facts and figures without context. We can think of this as the raw input to the information system, which the overall goal of the information system is to process this data and eventually turn it into meaningful and timely information. Finally, we have procedures and people. These form the human components of an information system, similar to how hardware and software form the computer components or the technology components. People include anyone who operates or services the computers in the system, anyone who maintains the data, supports the network, or in any way uses our information system. Procedures are basically software for humans, that is, instructions for people to follow when using the information system. So this brings us to the next question in the chapter. What is MIS? In this case, MIS stands for Management Information Systems. Management Information Systems comprise the development and use of information systems that help organizations achieve their goals and objectives. This is a fancy way of saying that MIS is an information system for achieving some business goal or objective, such as producing information for decision-making purposes. The study of MIS involves studying how information systems are created, how they are best utilized, and if they align with the goals of an organization. In simple terms, what is this information system going to do for our business? And once we create it, does it do and accomplish the goals effectively? As such, MIS has three key elements: processes and procedures for developing and using information systems, the information system itself, and the goals and objectives an information system is trying to achieve. So at this point, you might be saying to yourself, I'm not a computer science student or an engineer. Why do I need to know how to create or use an information system? Once I get out into the real world, I'll have someone out there to do it for me. And to some extent, that's true. In large organizations, there likely will be people dedicated to those tasks. But how will you, as a manager or even an owner, be able to make the correct and informed decisions about the creation, acquisition, or use of information systems if you don't understand them? Far too often in real life, we see managers or even sometimes corporate executives making horrible decisions regarding technology because they don't understand it or its limitations. This is a big problem, as there are many companies and contractors out there that would love to take your money and develop or sell you an information system that's not technically feasible, or even worse, won't accomplish your goals. If you don't have even a high level understanding of these systems in the end, you'll be left with a massive expense and nothing to show for it. So, what can we do to prevent that? You need to take an active role in the creation or acquisition of these systems. Don't leave it to someone else or trust that the sales team selling you the system is blindly telling you the truth about what it's capable of. You need to ask critical questions, such as, how does this system accomplish our goals? Or what new opportunities does this system enable? And you will need to know how to use your information system. After all, what is the point of creating an information system if you or your employees don't know how to use it? As we already mentioned, MIS needs to aid in achieving some objective or goal. Another unfortunate trend we sometimes see in real-world business is using a new technology purely for the sake of using it, rather than it enabling some new opportunity or better accomplishing a business objective. This often happens when a new technology is promoted heavily in the media, and there's a fear of missing out or that the company will be left behind if they don't adopt it immediately. Let's take a look at an example. And let's pretend that we are the owner of a small but successful business, a restaurant in this case, that has been in business for a few years now. You have a point of sale system that is essentially a computer combined with a cash register. It's a bit out of date, text-based, and employees have to enter orders on a keyboard. The software was free and requires little maintenance, but occasionally some employees complain about it not being user-friendly. One day, a salesman comes into your restaurant selling a modern point-of-sale system. Their system has a beautiful touchscreen graphical user interface, wireless card reader, and even a phone app and QR code reader for a custom coupon or point system. It has a monthly cost as well as a significant setup fee in terms of hardware costs. So, as a business owner, you're not quite sure. Your current system is sort of out of date. It's mostly DOS-based screens, and your staff has to type in the orders. And they have been complaining about it a bit. But your primary interest right now is how to get everything working with Skip the Dishes and those sort of remote ordering systems, rather than necessarily updating your graphical user interface. However, that point system is interesting and could attract more customers to your business. However, restaurants also operate on a very thin margin, which means adding monthly costs could be a significant setback. So I want you to take a few seconds and think about what kind of questions you'd ask the salesman. What would be the benefits and downsides of modernizing your point of sale system? And would you make an investment to update the system? So I'm going to put a clock on, take a few seconds, think about it, and maybe write down a few points. And we're back. When answering these questions, the key thing to keep in mind is the goals and objectives of the MIS. Does this more modern point-of-sale system help fulfill some business objective? Does it present any new opportunities for the business? At the end of the day, how will this new system make more profit and increase my business's margin? There are two different ways we could think about this case. Either could be correct depending on the circumstances of the business in question. The current point-of-sale system is not user-friendly and is a bit ugly, but will upgrading it attract any more customers or reduce costs? Sure, the new system looks fancy, but most of these enhancements are just minor quality of life improvements that do not serve a business purpose. You could argue that they would reduce training time of new employees, but we are a small restaurant business, so employee turnover could be small, and this reduced training costs might not offset the new monthly cost of the system. On the other hand, maybe this new system does accomplish some goals. The new point system feature could allow us to retain more customers, track what they are ordering, and allow for direct advertising to them, assuming they have provided us an email. The new point-of-sale system might also allow us to better track where our inventory is going and keep an eye on employee performance. But will these benefits outweigh the cost of the new system? What questions should we be asking to find out? Well, I'll give one away. We did mention that we are interested in sort of integration with things like Skip the Dishes and other online ordering platforms, but the salesperson didn't mention anything about that. So if that was one of our more immediate business goals, maybe we should ask about that. While we've been talking about information systems and MIS, one question that may be occurring to you is, how is this all different from IT, or information technology? Information technology and information systems are two closely related terms, and unfortunately, they're often incorrectly used interchangeably. They are not. They are distinct concepts. Information technology is only the raw technological components of an information system, including all hardware, software, and data components. This means if an information system is comprised of hardware, software, data, procedures, and people, information technology only makes up the technological components of that information system. The key difference here is that information systems are information technology plus the human components, procedures, and people. In practice, IT is responsible for maintaining the information system and keeping it running. An IT department would be responsible for installing software, replacing broken hardware components, managing and storing data, and monitoring the health of the information system. IT is not concerned with achieving goals or objectives, and is solely focused on keeping things running. It's only when IT is embedded in an information system, that is, when people and procedures are added, does it start helping to accomplish a business's objectives. Information systems make IT useful. Let's now turn our attention to how information systems help our business gain a competitive advantage. First, we need to define a few terms. Competitive advantage refers to factors that allow for a company to produce goods or services better or more cheaply than its rivals. Why is this important? Well, if we can manufacture our products more cheaply, that means less money going out, which means more margin for our business. Or alternatively, we could pass that savings onto the consumer and be more price competitive than our rivals. This could mean more sales, more money coming in, and thus more margin. Also, a better product potentially means more sales, which again means more money coming in and more margin. So how does this relate to information systems? Well, consumers have been accustomed to yearly advances in technology and service. They expect it to be free or low cost, such as Gmail or Facebook. They expect it to be high quality of services that makes no errors or mistakes, and they want it right now, with little wait. It's not hard to see these trends in real life. Take, for example, the case of Amazon. In the early 90s, it was not very common for retail stores to have an e-commerce website. Simply having their business hours listed and their current contact information would be what most customers would come to expect from a business's website. Then, as technology advanced and businesses like Amazon started to show the value of online retail, customers started to expect more. They wanted to be able to make purchases online, or at least see what items were in stock at a brick-and-mortar store. Retail had to catch up and start offering these services. Next, Amazon started innovating in regards to how they did deliveries, creating their own distribution network and delivery services, which allowed for overnight or even same-day deliveries. Consumers again started expecting this level of service from other retailers, and other retailers have been pushed to explore faster delivery options or in-store pickup. It's at the point where small retail businesses are struggling to stay afloat as Amazon's competitive advantage has become so great it is even starting to impact local and niche markets. The point here is that if your business remains stagnant and is not constantly adapting to new trends and technologies, you'll quickly start losing out to rival businesses that are. Customers will start expecting a higher level of service, and you might find your profits suddenly disappearing if customers are turning to alternatives that meet or exceed their expectations. So, what are some of the next big technologies and trends that will reshape business that we will have to be aware of so we can adapt to? Well, lucky for us, the Information and Communications Technology Council of Canada, or ICTC for short, publishes quite a few reports that try to predict these kinds of future trends, and have provided us a list with the top 5 key transformative technologies. These are virtual and augmented reality, 5G mobile, 3D printing, blockchain, and artificial intelligence, or AI for short. Now, before I go into each one of these, one important thing I should mention is that when you are first considering a new technology for your business, you need to keep a skeptical and critical mindset. You should be constantly asking, what goal will this technology help solve? What opportunities will this technology enable for my business that were not possible before? Is this technology going to be the next big thing my customers are going to expect, or it will simply be a fad? And what are the real-world limitations of this technology? Far too often, businesses will adopt a technology simply because it has a significant media attention without asking what objectives it's going to solve for them. We also often see businesses or individuals investing heavily into new technologies with little understanding of the technology or what its real limitations might be. If you don't understand the technology or its limitations, you don't know if what you are investing in is legitimate, a waste of time, or even an outright scam. So let's take a look at a real-life example, in this case, Theranos. Theranos was a breakthrough health technology company founded by Elizabeth Holmes in 2003 at the age of only 19. Holmes claimed that they had developed a wearable patch that was able to administer drugs to patients remotely and even monitor their blood constantly. She was so certain of their ability to create this product that they patented the idea, and she dropped out of Stanford to found Theranos. Thanks in part to Holmes's connections, Theranos was quickly able to attract investors, and Theranos quickly grew to being valued at over $10 billion at its peak, making Holmes one of the youngest billionaires in existence. Theranos had partnerships with Safeway and Walgreens to do quick in-store blood tests, and was even named the 2015 Bioscience Company of the Year. So where is Theranos today? Theranos is out of business and Holmes is in jail, and her net worth is now zero.
A jury yesterday found former Theranos CEO Elizabeth Holmes guilty on 4 charges of misleading investors about her blood testing startup after a trial that lasted almost 3 months.
So what went so horribly wrong? The technology Theranos claimed they had never existed, and it's probably not even possible to create. You see, blood tests require quite a lot of processing by machines that are at least the size of a photocopier. Depending on the test, they might have to do things like react the blood with different chemicals, put it through a centrifuge, or even measuring how much light is reflected at certain wavelengths. Theranos was claiming that they could fit all of this into something the size of a patch or a small desktop computer. But we're simply not capable of miniaturizing things like centrifuges to that size, at least not with our current level of technology. The second issue was the amount of blood. Theranos was claiming to be able to do all kinds of different blood tests on a single drop of blood. But most blood tests are destructive. Mixing chemicals into the blood or running it through a centrifuge for one test will make it simply unusable for another. The claims that Theranos were making would have required them to be making breakthrough discoveries and innovations in multiple fields, any one of which in itself would have been a massive achievement on its own, and the grounds to found a company. Turns out Theranos was lying to investors and partners, setting up fake labs for the media to see, and faking blood tests using conventional blood testing equipment that they purchased from other companies. So why did so many people fall for it? Well, Holmes had a great story that the media loved. A young student dropping out of university, starting a billion-dollar company all on their own, and changing the world with a breakthrough medical technology. It makes for a great story. It's also a technology we'd all love to have. No more needles, just put a patch on or a finger prick, and you're done with it. Holmes was also very well connected and attracted many impressive and well-known investors, employees, and board members. However, few had any kinds of medical backgrounds. How could investors have avoided this? Well, there were a lot of red flags people ignored because they loved Holmes's story and wanted the technology to be real. Some understanding of the technology used in blood tests and medicine would have quickly showed that these claims were unrealistic, and the fact that Theranos never published any peer-reviewed research, despite claiming to have made revolutionary advances in multiple fields, should have been a grave concern. Safeway and Walgreens saw the opportunities that this technology could accomplish if it had been real, but their fear of missing out made them partner with Theranos before understanding the technology and its limitations. With that cautionary tale done, let's get back to talking about each one of these technologies. First one up is virtual and augmented reality. Virtual reality, or VR for short, allows us to experience a simulated world using a VR headset such as the Steam Vive. That would be shown here. Users can interact in the virtual world by using motion controls or simply moving through the real-world environment with sensors matching their movement in the simulated environment. Currently, the primary use for VR has been entertainment, such as video games, but we're starting to see applications in education, medicine, and even business, such as virtual business meetings held in a VR space. Augmented reality is a similar technology, but rather than placing you in a completely different virtual world, it uses a camera or clear lenses to project something over your real-world environment, such as a game or heads-up display. This technology has been implemented in a limited form in games like Pokemon Go or Pikmin Bloom, which encourage players to go out in the real world and visit locations and use their phone to interact with the game elements that can only be seen through an overlay on the phone screen. However, there are also more expensive and complex implementations, such as Microsoft's HoloLens. This is aimed more at business applications, such as showing employees interactive instructions when doing a manufacturing project or repairing some machinery. Perhaps one of the largest and most recent investments into this technology is by Facebook, now officially known as Meta. Meta is trying to create a virtual space for e-commerce, business, and entertainment they call the metaverse.
We believe the metaverse will be the successor to the mobile internet. We'll be able to feel present, like we're right there with people no matter how far apart we actually are. We'll be able to express ourselves in new, joyful, completely immersive ways, and that's going to unlock a lot of amazing new experiences. When I send my parents a video of my kids, they're gonna feel like they're right in the moment with us, not peering through a little window. When you play a game with your friends, you'll feel like you're right there together in a different world, not just on your computer by yourself. And when you're in a meeting in the metaverse, it'll feel like you're right in the room together, making eye contact, having a shared sense of space, and not just looking at a grid of faces on a screen.
The idea is that this would evolve the internet from a mostly static web page-based medium into immersive VR environments that users could travel through and interact with while doing what they are now normally doing through web pages. And that would be things like visiting e-commerce sites like Amazon, chatting with friends, or attending business meetings, such as we do now over Zoom. For Meta, this would enable them to sell virtual real estate and advertising, as well as access to the metaverse, services, virtual property, and virtual commodities. Should the metaverse take off, the next big thing could be for businesses to have a virtual presence and VR storefronts in the metaverse, possibly even having employees that are manning virtual counters. Sounds amazing, but what are the limitations here? Remember I said we should always be aware of the limitations of a technology. One of the largest potential limitations comes in the form of the network effect. The network effect states that the value that is gained from a technology increases significantly as the number of users increases. What does this mean for VR? It means that if no or few people own a VR headset, the technology will likely fizzle out, sort of like 3D TVs did. For example, if few people are using VR because the headsets cost too much and do not offer enough advantages over traditional screens, no one will want to use it for business purposes such as meetings or shopping on the metaverse. And any projects that heavily utilize VR will likely be a failure. There's also a bit of a catch-22 here for VR. If no one owns a VR headset, no one will make VR applications and games. If there's no VR games or applications, no one's going to want to purchase a VR headset. It sort of goes round and round like that. The only way to break out of this cycle is for the price of the headsets to fall significantly, so consumers are willing to take the risk, or for companies to take a significant risk in investing in VR before the user base is there, such as Meta is starting to do now, and Steam has done a bit in the past. Second thing to consider is the lock-in effect. That is, the network effects can lock in users and make it hard for them to switch technologies at a later point. Take, for example, the metaverse. If Meta is successful and first to market, most users will make a commitment to using the metaverse and technologies like VR headsets that support it. It would be increasingly difficult for new businesses to create successful VR space, as they would have to convince users to make the change, and there could be a cost to users to do so, such as buying new VR headsets, if they're not compatible with this new VR service. This means that once big players like Meta move into this space, it could be hard for others to gain significant competitive advantage from the technology unless they partner with a bigger player like Meta. And lastly, we need to be realistic about what the realities of the technology are. VR headsets are cool, but they're not magic or like plugging yourself into the Matrix. People often get motion sickness or significant discomfort after wearing a VR headset for any significant length. Also, while VR controls are fun and immersive, they might not be the best idea for all tasks like surfing the web, internet shopping, or attending a business meeting. Expecting people to do all of these normal activities in a VR space may be unrealistic for where the technology is currently at. Next up is 5G mobile. 5G here is referring to fifth-generation technology standards for cellular networks. What it means for users is faster and more reliable mobile high-speed internet for phones and other devices. This technology could be more transformative in a few ways. First, it enables activities like streaming video on the go that might not have been possible in the past. It also makes the internet more present everywhere. It could replace home internet, and all of your devices could simply have a 5G modem in them that would allow them to be connected at all times, anywhere you go. It could also be an enabler for other technologies that need more bandwidth, for example, like VR or cloud gaming. These could now be possible anywhere, while you're on the bus even. However, there are limitations. 5G is fast, but it requires many smaller cell towers that have less reach. This is fine in cities where you have many buildings to attach antennas to, and a large population to justify the cost of installing them. However, it means that rural communities that are already underserviced in terms of internet are going to miss out yet again. These communities also tend to be more racialized and poor, so we are further increasing the digital divide between the privileged and the underprivileged members of society. Now on to 3D printing. When many of us hear 3D printing, we might be tempted to think of science fiction-like devices that can replicate or make anything.
Tea Earl Grey hot.
The realities of 3D printers is a bit less magical, but still fairly impressive and exciting. 3D printers mainly come in a number of different varieties, but the most popular and affordable are fused deposition modeling, or FDM for short, and I happen to have one here that I could show you. So here we have a 3D printer. In particular, this is an FDM style 3D printer, which means that it lays down layer after layer of plastic, building on the last layer to make a 3D object. In particular, this is an Ender 3 printer. It's one of the lower end printers, but it's good for home use because it still gets a good print, and it doesn't cost as much as some of the big industry style ones. This one has had a few modifications during its life, so it can print to hotter temperatures, which means it can print more materials, and it's changed the build plate and a few other things, just minor upgrades. Do note, though, if you wanted to start getting into a hobby like this, that these lower end printers, like the Ender 3, do take a ton of maintenance and calibration to get working properly. So the whole goal with these 3D printers, especially the FDM style, is to go from a big spool of plastic filament, and basically all that is just plastic that's been extruded in a nice line. It's kind of like weed whacker style plastic. And it takes this, pulls it off the roll, and turns it into a 3D object, if everything's going correctly. So one of the choices you have to make when printing is deciding what kind of material you want to use. So there is quite a different number of filaments. This one is PETG. It's sort of like in the middle between hard to use and good results of print. But the most commonly used one is something called PLA. This is a real easy plastic to print. Gets great looking prints, especially fine detail, but they tend to be a little bit weaker and they're not that heat resistant. They could melt in your car, for example. But both PLA and PETG have the advantage of you can print them on a home printer like this without many modifications. Other materials, like ABS, are a lot stronger and they're a lot more heat resistant, but the problem is you need an enclosure, basically a box around the printer to print them to keep the air temperature warm, and these types of plastics, ABS in particular, tend to vent some toxic fumes, which we wouldn't want to breathe in. So let's move on to how this thing actually works. Well, you can see the spool up here. So what happens while it's working is it pulls the plastic off the spool, comes down here, and down to a little box back here that's called an extruder. What the extruder is it's a little gearbox that sort of pulls the plastic. So it's going to be pulling this filament off the spool, and then it pushes it in to this tube here. So this is called a Bowden tube. And what it is, it's just a tube of plastic that has very smooth sides, and it's been lubricated a bit, so there's very low friction between the filament and the plastic. And it basically just guides the filament down and into this print head. So this is what we usually call the hot end. And it has a heating element in here and some fans that allows it to melt the plastic. And then at the bottom right here, we have a little nozzle that shapes the plastic into a very thin line, usually about 0.4 millimeters, and then prints it onto this build plate. So this is a heated plate that lets the plastic get a good stick to it, and then it puts down layer after layer of plastic, building it up until you have your object. So let's take a look at printing something simple. So in this case, we are printing a little toy computer that has the words CS1032. Note that it builds it from the ground up, doing layer after layer on top of each other until you have your object. You also might notice that there's a few weird things on the front and the back as it's printing. These are called supports. 3D printers aren't magical, so they can't print on thin air. So sometimes they have to print things called supports, which are just little temporary structures to hold the thing together while it's printing, that just snap off at the end. So now that we have seen a 3D printer in action, what can they be used for? Well, by far the most common and accepted use is in prototyping and research and development. When you're developing a product for the first time, particularly one with plastic parts or casing, it can be cost prohibitive to make a mold for each iteration of the product's design. Rather, you only want to make a finished mold once you're sure the product is ready. 3D printing allows product designers and engineers to rapidly create prototypes in a cost-effective way during product development, and only commit to molds and manufacturing equipment once the product is finalized. 3D printing is also very useful for highly customized or one-off jobs, where you want to create a single instance of something rather than mass manufacturing it. For example, the occasional replacement part or a highly customized product that you're only going to sell a few units of. Some great examples of this are with custom orthotics, where your feet are scanned and then an orthotic shoe insert is printed for you that matches your foot exactly. 3D printing is also used in dental work to print custom dentures based on 3D scans of your mouth and any existing teeth. Even NASA has been exploring installing 3D printers on the International Space Station to provide an easy way to create new tools and parts that might be needed. However, like all technologies, there are limitations. First and foremost, they're not magic, and most 3D printers can only print one basic material type, most commonly some type of plastic or plastic composite. This means you can print the plastic parts of your product, but not necessarily any electronic components. 3D printing is great for one-off jobs, but it's not feasible for mass production. 3D printers tend to be slow. For example, to print this one little computer here that we saw printed earlier with CS1032 on it, that took about 7 hours on my own printer, and it only made one of them. They also cost a lot more than injection molding in terms of raw materials, maintenance, and electricity. The strength of the parts they create is also weaker in most cases than those created with a conventional mold. Also, even if the plastic used is food safe, the way the 3D printer works, by putting layer after layer after layer of plastic, creates little micro holes that bacteria could grow in. So 3D printing tends to not be great for anything that would be touching food or your customers' mouths, so no customized mugs or things like that. The machines themselves are also often very high maintenance and expensive. It's not a technology you can expect your customers to have access to or be able to use unless you sell to a very specialized market. That means a plan like trying to save money by having your customers print replacement parts rather than mailing them out might not be feasible. There are also environmental issues to consider with 3D printing. 3D printing uses a lot of energy in plastic. Failed prints, calibration parts, and supports all generate plastic waste, and this can add up fast. This, shown on screen right now, is just the waste that I've personally created using my own 3D printer over the last 3 months, and I'm not exactly a heavy user of it. Some filament manufacturers will try to tell you that plastics like PLA are biodegradable or recyclable. However, in practice, neither of these are true. PLA takes almost 100 years to break down naturally, and almost no cities offer special recycling for PLA, even if it technically can be melted down again. I try to save mine and melt it down into blocks or things that I can use in other projects, but most people aren't doing that. There are also many legal issues surrounding 3D printing, particularly regarding copyright. For example, in our textbook, they talk about Vulcan Security investing in using 3D printing to make replacement drone parts. One wonders what the company that manufactures those parts would think of Vulcan's printing their design. Even if it's not legally copyrighted, it might potentially hurt their business relationship with their suppliers. Next up is blockchain technology. This is the technology that powers cryptocurrencies like Bitcoin and Ethereum. In simplest terms, we can think of the blockchain as a digital ledger book that everyone has access to read, but can only be written to under certain rules. For most cryptocurrencies, this ledger contains a list of transactions that can be used to determine who owns how much of the currency. The original idea of cryptocurrencies were to be distributed digital currencies that had no central control and were deflationary by design. However, in practice, they have been used more like a security than a commodity. That is to say, they have been used more as a speculative investment as opposed to a currency for actually going out and purchasing goods with. Recently, the blockchain and smart contracts have given rise to non-fungible tokens, or NFTs. These are tokens that cannot be subdivided and contain a small amount of text, like a hyperlink. The current owner of each token is recorded on the blockchain, as well as the rules under which it can be sold or transferred to another person or account. In most cases, these NFTs contain a hyperlink to some image or media. Now, what owning an NFT means is up for debate. Some have claimed that it gives ownership of the media it links to. However, without some outside prearranged contract between the seller and owner, this is not the case. NFTs do raise a lot of questions both legally and from a technology standpoint. If you need some outside agreement or contract to give the NFT meaning, did you really need the NFT in the first place? After all, you could have had a lawyer write the same contract for licensing of the same media without involving an NFT at all. Some have suggested NFTs might have a place in games and the upcoming metaverse as a way to sell digital content and property. However, once again, this is questionable, as for the same amount of work, any game or VR developer could simply create their own marketplace off the blockchain and retain full control over all content in their virtual world. This, however, has not stopped companies like Konami and Activision from exploring their use in their game-related products. The last technology we'll be looking at is artificial intelligence, or AI. Just like 3D printing, the first thing you might think of when you hear AI are examples from science fiction. In reality, however, when we talk about AI, we are talking about machine learning. Machine learning is all about classification, or in simple terms, if you are given a big data set of examples, how can we use a computer to automatically learn from that dataset and classify a new instance of data? For example, Netflix uses machine learning to predict what movies you might enjoy and provide tailored movie recommendations to each user. They're able to do this as they already have a large database of users and their movie preferences to learn from. Amazon Echo, Siri, and Google Home all use machine learning for their home assistants. In particular, they are using voice recognition and natural language processing to understand and respond to spoken commands. Google also makes heavy use of machine learning in its products, for example, spam detection for Gmail, in search, and in targeted advertising, and in image classification or recognition for things like Google Image Search. Currently, AI is very good at doing very specific classification tasks when given a large number of examples to learn from. For example, classifying movies into groups that you would like or dislike, or classifying email as spam or not spam, classifying words in speech, or classifying objects in an image as being identified as like cars, houses, roads, trees, animals, and so on. However, current results become less ideal when the task is more open-ended, like driving a car safely. Applications such as self-driving cars still have a significant way to go before they will be market-ready, and businesses investing heavily in them, like Tesla and Uber, are taking a significant risk by attempting to adopt them this early. However, should this risk pay off, it could quickly become a significant competitive advantage for these companies. My goal of going through each of these technologies and discussing some of the limitations with you is not to scare you off using them in your business, but rather to help you understand that adopting new technologies, especially transformative ones, is not without risk, and the best way to manage that risk is to having a good understanding of technologies and what they are capable of. So we've talked a bit about a few specific emerging technology, but more generally, what is the shape of things to come? Well, Moore's law might give us a few hints. Moore's law states that the density of circuits on an integrated chip doubles approximately every 2 years or so, and to date, it has shown to be quite an accurate prediction. Shown here is a logarithmic graph that shows the number of transistors on a microchip over time, and it generally fits Moore's prediction. The implications this has for technology are quite profound. If we can fit more components on a chip of the same size, that means we can make faster computers or computers that could store more data. Since this amount is doubling every 2 years or so, this means change and improvement is quite rapid. It also means the cost and size of devices will continue to drop at a rapid rate. But will Moore's law keep going on forever? Well, by the technical definition of doubling more components on a chip, probably not, as we'll eventually run into technical limitations. There's only so small you can physically make things. However, the general concept of technology rapidly advancing in a short period of time and doubling in some way every 2 years will likely remain true in other ways. For your business, this means you will always have to be aware and stay up to date with new technology, or a rival who just upgraded could quickly gain a competitive advantage. Another report by the ICTS, in this case the Jobs 2.0 report, makes some additional predictions about trends we will see in the next decade. These include the price of storage dropping to where it's almost free, or the cost will be negligible. In particular, they mean the cost of cloud storage, or storage on a remote service like Dropbox, OneDrive, or Amazon's cloud services. For businesses, this could be a big deal, as storing massive amounts of data will be trivial in terms of cost, which could enable things like more advanced data analytics, or machine learning, which benefits from a large dataset, which needs, in turn, a large amount of storage. And that brings us to our next prediction, that analytical software will reveal hidden information. That is to say that new technologies like machine learning will be able to process massive datasets and produce information and insights into things like customer behavior and preferences that we are not possible to derive in the past. We talked about information being one of the most important commodities for business. By changing how we gain information, we change how we make decisions and run business. We also talked about 5G, and this ties into the prediction that the real world and the virtual world will collide as wide area networks become cheap, reliable, and widely available. 5G could mean having high-speed internet wherever you go, and all devices connected at all times. VR also brings the real world and virtual world closer together in a more immersive way. Lastly, these trends will all enable deep, powerful innovations that will be felt in almost every industry. And we can already possibly see the starts of this, or at least companies attempting to create these innovations. Tesla and Uber are investing heavily into AI for self-driving cars. Meta is investing heavily into VR with their metaverse. We see Bitcoin and Ethereum creating whole new industries around cryptocurrency and NFTs. And 3D printing is starting to slowly make its way into people's homes. The question for you as a potential business is, how will you attempt to adapt to these changes? How will you know what new technologies are right for your business and what will accomplish your objectives? Well, a start to answering these questions is an understanding of the technology, at least at a high enough level that allows you to make informed decisions about them. And that's what this course is about. This course is not just about Access and Excel, although we will be working with that software. Rather, it is about understanding information systems and getting you to the point where you have a good enough understanding to make informed decisions about them. We want you to be the next Netflix or Amazon and not another Theranos. That's all I have for you in this video. If you want to get a head start on next week, start looking at Knowledge Extension 4 in your textbook and reading all about Microsoft Excel and spreadsheets. Thank you for watching, and have a great day.